So you are welcome back again to Eben's mathematics class. Eben's mathematics class, that is the EMC. Eben's mathematics class. Today you are going to look at finding the inverse of what? A 2 by 2 matrix. Finding the inverse of a 2 by 2 matrix. Don't forget to subscribe to what? The channel, okay? It is EMC for SHS. EMC for SHS. Don't forget to subscribe to the channel. So subscribe to the channel. Today we are going to look at what? Find the inverse of a 2 by 2 matrix. This class is what? An SHS class for elective mathematics and core mathematics. So let's look at finding the inverse of what? A 2 by 2 matrix. So the inverse of a matrix A is the what? Is the matrix A inverse. Okay, the inverse of matrix A is the matrix A inverse, such that the A multiplying A inverse is equal to A inverse multiplying A. So when a matrix what multiplies its inverse, it gives us what you call the unit matrix. So when a matrix multiplies its inverse, it gives us what? The unit what? It gives us a unit what? Matrix. Okay, so take note of what? Take note of that. It is only possible to calculate the inverses of what? Square matrices. Okay, it's only possible to calculate the inverse of square matrices if the determinant of a square matrix is 0. If the determinant of a square matrix is 0, then the matrix is called what? A singular matrix and has no what? Inverse. Take note of that. The matrix is called what? A singular what? Matrix and has no what? Has no inverse if the determinant of that matrix is what? Is 0. Okay, and also if the determinant of what? A square matrix is not 0, then the matrix is called a non-singular matrix and has an inverse. So if the determinant of a square matrix is not 0, then the matrix is called a non-what? Singular matrix and has what? An inverse. Okay, but at this level only the inverses of what? 2 by 2 matrices shall be what? Considered. Okay, so you are only going to consider that one. So let's say you are given what? You've been given A is equal to, the matrix A is equal to what? A, B, C, D. And we are asked to calculate the inverse of such a matrix. This is the pattern. So if the matrix A is equal to A, B, C, D, or the 2 by 2 inverse of a matrix, or the inverse of a 2 by 2 matrix A is equal to A, B, C, D, is given by the first thing is given by you're looking at the formula. So it's given by the matrix, this matrix A. We are going to find the inverse. So we have the A inverse. This is how we write the A inverse. Okay, this is how you write or the A inverse. You write A and you bring your power or the exponent what? Negative what? 1. Negative 1. So you write A inverse is equal to 1 over determinant of A, that is that A. 1 over the determinant of what? A, that is that A, this A. 1 over this determinant of A, okay, which is equal to D minus B minus C A. So this is how what we mean. Okay, the 1 over determinant A is find the determinant of this matrix, as we have learned about how to find the determinant. So you find the determinant of this matrix, you will cross multiply A multiply D minus B multiplying C, then you get the determinant of what? That matrix. So 1 over what? The determinant, the answer you had for the determinant. So 1 over that answer here is equal to, then when you get here, this is A, B, this is A, C, D, but the positions have what? There's been some changes here. So when you get here, what you're going to do is that after getting the determinant, this is equal to, you will interchange the positions of A and D. So A will come here and then D will go to the other side, as we have A here and we have D here. See, they have interchanged their positions. Okay, yes, then you maintain the positions of B and C. So B and C will be in the same, their same be in their same positions, but you will negate them. You will negate B and you negate C, as we have done here. Have you seen it? Yes. So you interchange the positions of A and D and negate B and negate C. Okay, then after that, you expand. Okay, you expand to get your final answer. So the determinant A, this is how to calculate for the determinant. The determinant A, this is how to calculate for it. AD minus this BC minus this BC. So AD minus this BC. Then you get your determinant. Then you write 1 over the determinant. Then you interchange the positions of A and D here, and then you negate B and C as you maintain them in their usual positions or where they are. So let's look at the first example. We are going to use this idea to do the example we have here. So this is the idea you have to use to solve it for what A, E, and an inverse of what a matrix. So example 1, if A is equal to 1, 2, 3, 4, okay, find the inverse matrix A inverse of A. So we are going to find what this is the matrix here. We are asked to find the A inverse. Okay, we are asked to find the inverse of this matrix A. So we are going to find the inverse of this matrix A, which is 1, 2, 3, 4. Okay, so what we are going to do is that, as we know earlier, you will come and write your formula. A inverse is equal to 1 over that A. 1 over the determinant of A. Is equal to, then you bring your formula, you write your 2 matrix. What matrix do we have here? We have 1, 2, 3, 4. 1, 2, 3, 4. Okay. Yes, so there is it. So that's it. Yes, 1, 2, 3, 4. Okay. Yes, so the next thing we have to do is that what? If you look at our steps, the first one, after doing this, what you have to do is that you calculate for what? Your determinant. Okay, you will calculate for a determinant. Make sure you have the determinant already, or you have the determinant. You calculate for the determinant first, so you write it and then you calculate for the determinant. Okay, someone can decide to erase this and write A, B, C, D before coming to substitute, but it doesn't change anything. So calculate for a determinant first. Okay, so we have this one is equal to 1 over, you're calculating for the determinant. For the determinant is what? That determinant, that A, you can calculate it somewhere and come and write it. But that A is equal to what? What is 4 times 1? 4 times 1 is what? Is 4. Minus 3 times 2 is what? 6. Okay, therefore the determinant will be what? Minus what? Minus 2. Okay, so minus 2 is our determinant. So now we have our determinant. We come to substitute this minus 2 into our formula, which is A inverse equal to 1 over that A. So we are going to get A inverse is equal to 1 over that A. Okay, 1 over that A. Determinant, we had what? Negative 2 as our final answer for the determinant. So we have 1 over negative 2. Then it is equal to 1 over negative 2. No, is it multiplying or is equal to? It is multiplying. Okay, yes, it is multiplying. So what we are going to do is that we are going to what? Multiply it. It is multiplying. The determinant is multiplying. So what we are going to do is that we are going to what? Multiply. So here I will take away the equal sign. Okay, yes, let me take away the equal sign so that it will yeah, so it is what? Multiplying. Okay, so here I'm taking away the equal sign. The determinant is multiplying the matrix. Okay, so we are going to get A inverse is equal to what? Negative 2 multiplying the matrix. What is the matrix? Now what you are going to do is that after calculating for your determinant, now you have a determinant. So what you are going to do is that we are going to what? We are going to interchange the positions of A and D and then negate B and C. We are going to interchange the positions of A and D. So if you look at, you come to the formula you see here, we interchange the position of what? A and D. So A came here and then D also came here. Okay, and we negate what? We negated B and what? And C. So we are going to use the same thing here, the same idea to do the same thing, to do same here. So here we are going to change position of A and D. So we have 4 will come here and then 1 will also come here. Okay, then we negate, maintain the positions of 4, we maintain the position of what? We maintain the positions of 3 and 2, but we negate them. So here will be 3, but we negate it. We negate it. So we maintain their positions, but we negate it, and then we write 2 here and we negate 2. Okay, yes, then we'll bring our brackets here. Bring our brackets here. Okay. Yes, so making this -2. Yes, so then after that, what we are going to do is that we are going to expand. We are going to multiply 1 over -2 by every element in this bracket. So we multiply 1 over -2 by 4, multiply 1 over -2 by -2, multiply 1 over -2 by -3, multiply 1 over -2 by 1. Then we get our final answer. So we are going to do it. So what we're going to do is that now -1 over 2 multiplying 4 will give us what? 2 will cancel, 2 go here, 1, 2 go here, 2. -1 times 2 give us what? -2. So we are going to have what? Negative what? 2. So this one is equal to -2. Okay. Then -1 over 2 times. -1 over 2 times. Then we are taking this -2 times -2. Now, what you're going to do is that -1 over 2. -1 over 2 times -2. Okay. Yes. So here we are going to have the negative will, so -1 over 2 times -1 times negative. So that will be giving us what? 1. So that will be giving us 1, because negative times negative should give us what? Should give you what? A positive answer. So negative multiplying negative should always give you what? A positive what? Answer. So -1 over 2 times -2 will give us what? A positive what? Positive 1. Okay. So that is what is it. So here we are going to get positive what? 1. Okay. We are going to get positive 1. Then we come to -1 over 2 times -3. So -1 over 2 times -3. Okay. So -1 over 2 times -3. The same thing. We are going to get what? We are going to get positive 3 over 2. So positive 3 over 2. Okay. Because negative times what? Negative. So we're going to get positive 3 over 2. Then the last one will be -1 over 2 times 1. Then that will also give us what? -1 over 2. Same -1 over 2. Okay. Because -1, any number multiplying 1 will give you the same number. Give you the same number. So -1 over 2 times 1 will give you the same -1 over 2. So we are going to write them according to as they are. So when we multiply -1 over 2 times 4, we had what? We had -2. We are going to write them. So we have -2. Then when we multiplied -2 times -2, -1 over 2 times -2, we had what? We had 1. So write 1 according to what? Where the position it is. It is, yes. So then we come to -3. When we multiplied -1 over 2 times -3, we had what? We had 3 over 2. So we had 3 over 2. We had 3 over 2. And then when we multiplied -1 over 2 times 1, we had what? We had the same -1 over 2. So at the end of the day, this is what our final answer for what? For the inverse of what? A matrix. So don't forget to subscribe to the channel. It's EMC for SHS. Okay. Yes. So this is our final answer. Anytime you're given a matrix to multiply, or sorry, to find the inverse of the matrix, don't forget to follow this procedure. This is how to what? Find the inverse of what? A matrix. First of all, you find your determinant. Okay. You find your determinant. After getting your determinant, then you write 1 over the determinant, the answer you had, multiplying what? Then after writing 1 over the determinant, which is the answer, multiplying, then you interchange the position of A and D. Changing the position of A and D, and negate the position of, negate B and C, but you maintain them in the what? In their position. Then what? You multiply every element in the what? In the bracket by 1 over 2. The answer you have for the determinant, you multiply, and then you write what? Your final answer. There's no need for worrying yourself doing all this calculation. You can use calculator and then write your final answer straight as I have done it. we have done it here as we have done here. Okay, yeah, so that's how to find the inverse of a matrix. Thank you very much. See you again.